In a previous video, we made this class diagram for our Plant Places mobile project, where we have the superclass activity that comes from Android itself. We have our UI package. We have a data access package, or we could just call that some kind of non-UI backend like a service. And then we also have a package that contains our DTOs, which we could also call Java beans. We could call them nouns. We could call them pojos, lots of other things like that. So in this video, we are going to start implementing this class diagram, and naturally it's going to take many videos to work it out fully, but one of the things we want to ask is, where do we start? One thing I'll caution you with, if you have a class diagram like this, don't start by making every single class and leaving it empty and call it to do, because that's just clutter. Only work on one feature at a time. That's piece of advice number one. Piece of advice number two, because we have things nicely segmented here between UI and DAO, it makes it easy for multiple people to work on this project. Now, the contract that we have between UI and DAO is this thing, which is an interface. And remember polymorphism. A polymorphism says variable type tells us what methods we're allowed to call. Object type tells us what will happen when we call those methods. Now, adding interfaces into this equation of polymorphism allows us to leverage polymorphism as a tool to help us make flexible software, or software that anticipates the future. So, an interface can only be a variable type, not an object type. A class can be a variable type or an object type. The arrangement that we'll typically use is we'll have the interface be a variable type and a class be the object type. If that doesn't make sense, don't worry. We have plenty of examples that we'll use to explain that. But what that gives us is several things. First of all, it gives us a hard connection here to the interface, but not to the implementing class, which means we can change that implementing class at a later date as our requirements change. It also gives us enough information to start writing behavior-driven design or test-driven design unit tests, because we can write the tests against the interface before the class itself has actually been written. That's very powerful. So this is giving us a starting point. We want to start by writing the interface. But we know that the interface is going to have a method called fetchPlants, which accepts a string and returns a list of plant DTOs, a list being a collection or multiple DTOs. So really, before we can do anything, we need to start with this plant DTO. So let's do it in that order. We're going to start with the DTO, then we're going to go to the interface. After that, we'll probably wind this video down. We might go ahead and start to fiddle with the stub a little bit, but we'll wind this video down, and then we'll take a look at unit testing. So let's get started. I navigate over to our application, and I go to Project, and under Manifest Java, this is where, App Java, this is where we want to start our work. You notice that it's already created an activity, GPS a plant, and edu UC Jones BR Plant Places, which is fairly common. So similar to the package name that we have here, but not identical. It doesn't end with UI. It also kind of has a little different package structure, but nonetheless close enough for our use. So what I'm going to do now is I'm going to say, okay, right click, and then I'm going to say new, and then I'm going to say package. Now the reason why I want to do this is to make it easy to know what my sandbox is a data access object creator versus where the UI person in the project is going to work. So by segregating things into packages, it makes things a lot more organized. It also makes it kind of obvious where a UI class should go versus a different class. So we have our DAO. Let's do that one more time. I'm going to say new package, and we'll call this one DTO, or data transfer object. Under DTO, I'm going to right click and say new and say Java class. And here I want to represent a class that, or I want to create a class that represents a plant. So we're going to call this plant. We could also call it plant DTO. Either one will work for us. We'll stick with plant DTO. No need to indicate a superclass because this is a plain old Java object. It doesn't need to extend anything. So now I'm going to go into, oh yeah, sure, add it to GitHub. I'm going to go into plant DTO. One of the things I want to do is enhance the Java doc and say a plant has a genus, species, cultivar, common name. We could go on and on about that, but some kind of class level Java doc that describes the purpose of this class. Now, this is a traditional Java bean where we are going to define some attributes here. I'm going to say private, and then we'll say int GUID, which is like a global unique identifier, private string genus, private string species, private string cultivar, oops, and private string common. Later in this video series, I'm going to talk about Kotlin. We're looking at Java right now, but later I'm going to talk about Kotlin. One neat thing about Kotlin is it takes a lot of typing out of creating a DTO. It's possible to make a DTO in Kotlin in only one line, where here in Java, it's traditional to put our attributes on different lines and then physically generate getters and setters. There are advantages and disadvantages to both. I just want to give a little compare and contrast. So we don't have to write the getters and setters by hand though. What I can do is I can say refactor and then encapsulate fields and then tick all of these fields and it will apply proper encapsulation and refactor. What does encapsulation mean? It means that the data belongs to this class and is only accessible through a series of valves or getters and setters, whatever you want to call them. Gives us a little bit of protection around the data in the class. So at this point, our DTO class is created and we are in good shape. Now, let's go ahead and create the DAO interface. Let's remember what this interface is called. It's called iPlantDAO. It has a method called fetchPlants, which accepts a string search criteria and returns a list of our DTO objects. So back to Android Studio, and on the DAO, right-click, New, and then I'm going to say Java class. Now that is misleading because we're not creating a class, we're creating an interface. But in Android Studio, we select that on this step. We say, okay, this is going to be an interface, iPlantDAO. It used to be common to start interfaces with the letter I. That's no longer required, but I still do it. Why is that? Because if I called this PlantDAO, the implementing class would probably be called PlantDAO-impl. So you're still kind of naming it so that you know what the class is and the interface is. And gosh, I'll just put the I there. That way I'll remember what it is. Okay, and we choose OK. Go ahead and add to GitHub. And now I'm going to say public, and then we'll say list, plant DTO. Look at that. Do you see how it's auto-completing the plant DTO because we just made that plant DTO. Now Alt-Enter so that it imports list. And we called the method, I think, search or fetch plants. What was it? It was called search. Okay, so back to Android Studio, and we're going to say search, string, search term, if we want to call it that. And I think we're in good shape, and we simply terminate with a semicolon, and now our interface is good. Once again, we do like to be verbose with JavaDoc, especially in an interface, because good JavaDoc in an interface means that we can just reference that JavaDoc from the implementing class. So we'll say represent the data access operations for a plant. Okay. For the method search, I'll say, we'll do JavaDoc just like so. Given the search term, find appropriate matching plants. I probably should also add an exception onto this signature, but we'll come to that later. So search term, a text representation of the user's search term. Return a list of matching plants. Now, I'm going to go ahead and save. One thing I want to offer a bit of caution on here, just one moment, is your search really should just be a string unless you have a really good reason to make a more complicated search. Here's what Plant Places looks like right now, the website. Enter a plant name to search. Notice as soon as I start typing Eastern, it starts, that helpful text in the search box goes away. It brings down a list of matching plants. This is a more Google-like search. This is what's very common today. Put in the text. It can be genus, species, cultivar, or common name. So Eastern could be a common name. You see Cercis canadensis, Eastern redbud. But I could also say Cercis, which is the genus for that plant. Get similar results. What we want to avoid is the very first search screen that I ever made for Plant Places Mobile, which looks like this, which at the time made a lot of sense. So you could say, here's the genus, here's the species, the cultivar, the common name, so on and so forth. This used to be the only search available, and I remember I asked my wife to go to Plant Places and search for Eastern Redbud. She came to the search screen and said, okay, where do I put Redbud? And she had a good point. It's way too complicated. A simple text search like this is what we really need. I type in Eastern, which is a string. I get back a series of plants. So that's essentially what this method is representing, is take a search term, get back a list of matching plants. Now, one consideration, why is it that we're returning a list of plants and we had to do this DTO first? Can't we just return strings? Because isn't that what the user's seeing here when we start typing Eastern Redbud? Well, the user is seeing a string representation of an object. So it actually is an object under the covers. And that buys us a whole lot of benefit. Number one, object orientation. Number two, let's go back to plant DTO. And GUID, global unique identifier, so that's like a unique number. Genus, species, cultivar, and common, that's part of the scientific definition of a plant. So if you have a Fuji apple, the genus is Malus, the species is Domestica, cultivar is Fuji, Fuji is a trade name, and then common name is Fuji apple. That's how genus, species, cultivar, and common describe a plant. But let's say, okay, that's a global unique identifier, but what if I'm in offline mode and I need kind of like a local cache? I need something, I won't know the global unique identifier if I don't have network access. So what if I need to say private int cache ID or something of that nature? And then of course we can do the old right-click refactor and encapsulate fields. We can go ahead and generate a getter and setter for our friend cache ID. So you see I've now changed the internal structure of this DTO. Let's go back to the DAO and think about what we have to change there. And the answer is nothing at all. Because you see, the DAO only knows this DTO at a very high level. It only knows what the class is. It does not know the inner workings of the class. And that's one of the big advantages of object-oriented programming, and also paying close attention to your method signature, specifically what it accepts as a parameter and what it returns as a result value. Make sure that those are actually objects. Make sure they're not strings. And make sure you've composed your object well so that you can change the internals all you want and you don't have to change the method signature of any kind of behavioral method that's working on this object. So we can rearrange this DTO, DAO stays the same. So the DTO, you notice on the class diagram, the DTO is kind of sitting out here by itself. The DTO is something that's returned from this DAO layer over to the user interface layer. So the DTO is essentially an object that floats across layers without a hard dependency on any of those layers. It's just straight Java. You see, it doesn't extend anything. It's just a series of variables that happen to be attributes or fields or member variables, depending on what you call it, and a series of getter-setter methods that act on those variables. Nothing crazy, it's not extending anything or anything like that, so it's free to float from the UI layer to the DAO layer. That's kind of a common golden nail that goes across all layers. So DAO, we've just taken a look at this, and now we've put ourselves in a good position to do some unit testing of this. UI, we'll take a look at that separately because that's theoretically somebody else from the group. So I hope this video has been helpful. Next up, I recommend watching some videos that I'm going to make on behavior-driven design unit testing. Thank you.